So this video is on page 3, starting on number 37. This is a quadratic trinomial. You could attempt to factor, split, and solve, but I don't think it'll work, so we're going to jump right into the quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And when we use the quadratic formula, let's rewrite it with parentheses instead of the b and instead of the a and the c. All divided by 2 times a. So we identify the a value is 1, the b value is negative 10, the c value is 26. Let's plug in our b values of negative 10 right there and right there. The a value of 1 right there, and the c value of 26 right there. So with the calculator, let's go negative 10 squared, that's 100. So inside the square root we have a 100, and then we have a minus 4 times 1, that's still minus 4, and then times 26. We get 100 and what? 104. So we really have 100 minus 104. 104. Wow, that's ugly. And that is inside the square root. So instead of writing 100 minus 104, 100 minus 104 is negative 4. So let me rewrite my whole thing here. We have a positive 10 plus or minus the square root of negative 4 all divided by 2. So what is the square root of negative 4? 2i. I2, right? Okay, so 2i. So you have 10 plus or minus 2i all divided by 2. When you have addition of two terms or subtraction of two terms, right here you have both, and it's divided by a single number or a single monomial, you could split that denominator to each of them and divide each of them. So if you did split that 2 and divide it into each of them, 10 divided by 2 is 5, plus or minus 2 divided by 2 is 1, so you just have a regular I. So your answer for this guy really is the complex number 5 plus or minus I. It's actually two imaginary values. Let's move on to number 38. Again, same concept. It's a quadratic trinomial. If you tried to factor it, what times what is 7? That if you add together is negative 2. It's not going to work, so you're going to have to use the quadratic formula. Let's use the quadratic formula once again. X equals negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a. The a value is 1, the b value is negative 2, the c value is 7. So let's plug in the b value of negative 2 right there and right there, the a value of 1 up here and down there, and the c value of 7 right there at the very end. With the discriminant, negative 2 squared, that's positive 4. So you really have 4 take away 4 times 1 times 7. So you really have 4 take away 28. And if I do 4 take away 28, I'm really going to have a negative 24 inside that square root. So what I really have is a positive 2 plus or minus the square root of negative 24 divided by 2. You guys agree? Okay, now the square root of negative 24, well, first of all, let's just jot that down on the side. The negative sign becomes an I on the outside. And the square root of 24, you could actually break that down. It's not a perfect square number, but you could break it down to 4 times 6 and then split the roots. Square root of 4 is 2. Square root of 6 will stay the square root of 6. The I just comes down. Multiply I times 2. That'll become 2i square root of 6. So instead of the square root of negative 24, let's write down 2i square root of 6. So what I really have is 2 plus or minus 2i square root of 6 all divided by 2. And of course, if you're dividing two terms that you're adding or subtracting by the same denominator or monomial, you could split that monomial into both. So 2 divided by 2 is 1, plus or minus the 2 divided by 2 is 1 with an I and the square root of 6. It's kind of like reducing everything by 2. Everything becomes a 1. So what do you have left over? 1 plus or minus 1i square root of 6. So 1 plus or minus I square root of 6 is your final answer right there. I hope that makes sense, and I hope you guys are able to do it out in the final. One more practice problem almost identical to that. Let's do it. X equals negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a, where the a value is negative 4, the b value is 1, and the c value is negative 3. So let's do the math here. We have 1 squared, that's just going to be a 1. Then we have negative 4 times negative 4, that's positive 16, times negative 3. It takes you back to a negative 48. So you have 1 minus 48. 1 minus 48 inside as the discriminant value. So what we have is a negative 1 plus or minus 1 minus 48 is a square root of negative 47, all divided by negative 8. The square root of negative 47, the negative comes out, becomes an I, and 47 you can't break it down, so you would leave it like that. Negative 1 plus or minus I square root of positive 47, all divided by negative 8. However, check this out, guys. We never like to leave a negative in the denominator, so we could technically think a negative divided by a negative is a positive, right? But you'd have to do it to both. A negative divided by a negative is a positive, and over here, this sign divided by a negative is going to change that sign, but the plus changes to a minus and the minus changes to a plus. It's still plus or minus. So what I'm trying to say is your final answer that you're probably going to see on the multiple choice answer of the final is positive and positive. So your final answer will be 1 plus or minus I square root of 47, all divided by 8. No negatives out there in the front. Moving on to the next couple of questions. It says rewrite in vertex form. Well, in order for us to rewrite it in vertex form, we need to remember what vertex form is. That's y equals a parentheses x minus h close parentheses squared plus k. It's called vertex form because if you identify the h and the k, you technically identified your vertex. Your vertex is the coordinate hk. All right? Anyway, this obviously does not look like this. In order for us to change this to this, we need 3 numbers, 3 things. We need the a value that belongs in the front, and we also need a h and k, which is technically our vertex. Okay? So we have a standard form. Could you find the vertex of a standard form equation? This is way back this semester. How do we find the x value of the vertex? Anybody? X equals, it's a formula. There you go, negative b over 2 times a. So let's plug in negative parenthesis over 2 times parenthesis, and that'll give us the x value. And of course, the b value is negative 16, so let's put a negative 16 right in there. And the a value is 2. So we have a negative 16, which is really 16 divided by 4. So when I say 16 divided by 4, I'm really saying that my x value is 4. So this is the x value of our vertex. Now once we have the x and we need the y, how do we find the y? Substitute, plug it in. So you're going to take this x value of 4 and put it right here where this x is at, and also take it and put it right here where this x is at. Because x equals 4. Here are x's, put 4's right there. So let's do exactly that. 2x squared minus 16 times x plus 1. And we said we're plugging in 4's right in there. You could do all this with the calculator. 4 squared 16, 2 times 16, that's 32. Negative 16 times 4, that's, I believe, 64. I hope I'm right. Hopefully you guys could do that. Double check that on the calculator. Then plus 1 at the very end. So our y value is negative 32 plus 1. That's negative 31. Is that right? Okay. So our x value is 4, and our y value equals negative 31. So there's our vertex. X value is 4, y value is negative 31, which is technically our h and k value. Our h is 4, our k is negative 31. And all we need left to write in vertex form is an a value. And remember, the a value is simply the number in front, right? So this is the a value of our standard form trinomial, ax squared plus bx plus c. So the a value is 2. And we know that the h value is 4, and the k value is negative 31. So we need to plug that into the vertex form equation. Let's write it out here. Y equals a, which is 2, parentheses x minus h is 4, close parentheses squared, plus k, which happens to be a minus 31. So there's your vertex form equation. You have changed it from standard form to vertex form. 41. 41, let's do x equals negative b over 2 times a. That's the formula to find the x value of our vertex in a standard form equation. So our b value is 6, our a value is negative 3, right? The b value is 6, the a value is negative 3. We can keep that in mind. A value is negative 3. We're going to use that later. Let's actually simplify this. Negative 6 up on top over negative 6 on the bottom. That means that our x value is really 1. Okay, so we know x equals 1 of the vertex, that is. So let's plug in 1 to find our y value. So we're just going to rewrite the same exact quadratic trinomial, negative 3x squared plus 6x minus 3. Plug in that 1 value right in there and then simplify. 1 squared is 1. Negative 3 times 1 is negative 3. 6 times 1 is 6 minus 3 at the end. Negative 3 plus 6 minus 3, that is 0. So my vertex is really 1 for x, 0 for y, which technically means that my h value is 1, my k value is 0. So when I write my vertex form equation, y equals a parentheses x minus h close parentheses squared plus k, you're going to write y equals my a value. What's my a value? Negative 3. Anybody awake? X minus h. What's h? 1. The k value is what? 0. So if you put plus 0, no harm, no foul. However, multiple choice is not going to have that as an answer. They're just going to have it. Oh wait, I totally forgot about the square. Don't forget about the square. So there's your vertex form equation. Y equals negative 3 on the outside, parentheses x minus 1, close parentheses squared. Maybe I should box that in like the rest. Number 42, write an equation of a parabola that has a vertex 1, 5 and passes through 2, 7. Okay, so they want us to write an equation of a parabola. So what form would be good to use? Vertex form would be good to use. So once again, what is vertex form? It's y equals a parentheses x minus h close parentheses squared plus k. Now, if we had an a value, an h, and a k, I would just plug in the a, the h, and the k, and I'd be done. That would be my equation of the parabola that has the vertex 1, 5 and passes through 2, 7. Do they give us the vertex? Yes, they do. They give us the h value and the k value that you're going to put in right here and right there. But do they tell us an a value? No, they don't. They actually give us another point. And what is a point? A point is really an x value and a y value. So what we're going to do is plug in everything that we know to find out what we don't know. We don't know the a value. So let's plug in everything. Let's plug in the x right there where the x is at, the 7 right there where the y is at, the 1 where the h is at, and the 5 where the k is at. Let's do that. So instead of y, I want to plug in a 5. No, I'm sorry, I want to plug in a 7. Why is that? Because it's my y value of my coordinate is 7. So I have equals a. We don't know a. A is what we're going to try to find right now. We have open parentheses x minus h. What's the x value, guys? 2. Okay, so let's plug in 2 right there instead of x. Minus h. Minus, what is the h value? 1. So let's put a 1 right there. It is squared. And then plus k. What's my k value? 5. Again, my k value is 5. Put that right there. So I've plugged in my x, my y, my h, and my k all into the vertex form equation. That way I could solve for a. So let's do the parentheses first. 2 take away 1, that's 1. And when you square it, it's still going to be 1. So what we have here is 7 equals a times 1 plus 5. So you're not going to add 1 plus 5 before multiplying a times 1. So multiply a times 1 first. You're going to have the equation 7 equals a plus 5. To solve that equation, you're going to subtract 5 and subtract 5. That means that 2 equals a. You guys agree with that? So now that we know that the a value is 2, and we also know the vertex, which is a h and a k value being 1, 5, we could plug it all into the vertex form equation with the a, the h, and the k. So our answer is going to be y equals a, which happens to be 2, open parentheses, x minus h, which happens to be 1, close parentheses, squared, plus k, which happens to be 5. Ladies and gentlemen, this is your answer right here. Vertex form of the parabola that has the vertex 1, 5, and actually passes through the point 2, 7. Number 43. Same exact deal. They give us a vertex. So this is my h, this is my k, and they tell us that it passes through a point, and that point happens to be an x and y coordinate. So we're going to plug it all into y equals a parentheses x minus h squared plus k, the vertex form equation. So the y value is really a 1. The equal sign's right there. The a value we don't know. That's what we're going to try to solve. Open up some parentheses. The x value is negative 3 minus h. The h value is negative 1. And the k value is 4. And let's not forget about the square on the outside of the parenthesis. So now let's just do this math and solve for a. A minus minus changes to a plus plus. My new equation becomes 1 equals a times, what is negative 3 plus 1? That's negative 2, but you're going to square it, and then at the very end, add 4. So negative 2 squared is 4, but you don't add 4, you multiply it by a first. So what we really have is the equation 1 equals a times 4 plus 4. Again, you want to get a by itself, so you're going to subtract 4 to get rid of this 4, subtract 4. You're going to end up with negative 3 equals a times 4. You don't want that multiplication of 4. You're going to divide by 4, and yes, a equals a fraction, negative 3/4. No big deal. All you need to know is what that a value actually is, so when you plug it in right here, you'll put that negative 3/4 right there. So to write an equation in vertex form, you needed the a value, which we know is negative 3/4, and also the h and the k, which was given to us right here. So my answer of this equation will be y equals the a value, negative 3/4, parenthesis x minus h, which is a minus negative 1, which ends up being a plus 1 squared, plus k, which is a plus 4. Number 44. It says write an equation of the parabola that has a vertex negative 2, negative 1. So the h value is negative 2, the k value is negative 1, and it passes through the point, the x value of negative 1 and the y value of negative 2. So we're again going to plug it all into the vertex form equation. We're going to plug in the y values, the x values, the h values, and the k values, and we're going to solve for the a. As you could see, I plugged in my x and my y in blue. Here's x, here's y. And I plugged in my h and k in red. My h is right here, my k is over here. So let's simplify the parentheses and the exponent of 2. Minus minus changes to plus plus. So I really have a negative 1 plus 2, that's 1. And 1 squared is 1. And times a is simply going to be a, right? A times 1 squared is simply going to be an a, but you have a minus 1 over here at the very end, an equal sign, and a minus 2. So let me rewrite this up here. We have a negative 2 equals a minus 1. So how do I get rid of that minus 1? Simply adding 1 to both sides, and you'll have negative 1 equals a. Now that you know your a and your h being negative 2 and your k being negative 1, you could plug it all into the vertex form equation to get your final answer. So your final answer will be y equals a, which is negative 1, open parentheses, x minus h, which will be a plus 2, squared, plus k, which is going to be a minus 1. So there's your final answer for number 44. Y equals negative 1, or just negative. You don't even need the 1. Negative on the outside of the parentheses, x plus 2 squared, minus 1 at the very end. Let's look at this next type of question. It says, write each equation in vertex form, state the axis symmetry, the vertex, and the direction of opening. Okay, so once again, we're still dealing with vertex form. Vertex form is y equals a, parentheses, x minus h, close parentheses, squared, plus k. In order to write an equation in vertex form, you need three things. You need the h, the k, and also the a. The question is, do we know any of those three things based on this standard form quadratic trinomial? It says ax squared minus bx, or plus bx plus c. We know the a value. So at the very least, we know a equals 2. Now, we don't know h and k, and we should remember that h and k come from the vertex. So we need to find the vertex, right? The vertex is really a coordinate h, k. So if we found the vertex, we would know h and k, and we'd be able to plug it all in. So how do we find the vertex on this quadratic trinomial? Use the vertex formula. X equals negative b over 2 times a. So you have negative parenthesis over 2 times parenthesis. The b value is negative 8, the a value is 2. So a negative 8 right there and a 2 right there. You'd have a positive 8 over 4, which means your x value of your vertex says x equals, your x value of your vertex is 2. So x equals 2. If you're looking for the vertex, that first x value is 2. You need the y value. So once you have the x and you need the y, all you do is plug in that x value of 2 right here where the x's are at. So let's rewrite that equation. 2x squared minus 8x minus 1. And of course, we're plugging in that x value of 2 that we just found. Let's do the math. Exponents first. 2 squared is 4. 2 times 4 is 8. 8 times 2 is 16. Bring down the minus 1. So 8 minus 16, that's negative 8. Minus 1, that will be a negative 9. So my y value is negative 9. So technically, I have found my h value being 2 and my k value being negative 9. So my h value is 2, my k value is negative 9. So let's now just plug it all in to get our vertex form equation. Y equals a, we said that was 2. Open up some parentheses. X minus h, we said the h value is 2 also. Close parentheses squared plus k, which happens to be a negative 9. So instead of plus negative 9, I'm sure on the multiple choice answer, it'll just say minus 9 at the very end. So there's your vertex form equation right there. But notice on the instructions, it says also state, on top of the vertex form, says state the axis of symmetry. And I hope we remember that the axis of symmetry will always be x equals the x value of your vertex, which happens to be 2. So please write that down. That's the a of s, the axis of symmetry. It's x equals 2. And it says the direction, the vertex, we already stated the vertex, it's 2, negative 9. And it says, and the direction of opening. So does this parabola open up or down? Up. So we also need to write that it opens up. So there's a lot of details, a lot of answers, a lot of questions they're asking on each one of these. Of course, on the multiple choice, it's going to give you a list. They're going to give you the vertex, they're going to give you the vertex form, they're going to give you the axis of symmetry, and the fact that it opens up. Every single one has to be correct in order for that multiple choice answer to be correct. Let's jump to number 46. Once again, we're going to go with x equals negative b over 2 times a. So we go negative parenthesis over 2 times parenthesis. The b value is 6, the a value is negative 3. You can end up with a negative 6 over negative 6, which means that your x value is positive 1. So the vertex x value is positive 1. When you want the y value, all you have to do is simply plug it into the original equation and you'll find your y. So we really have negative 3x squared plus 6x minus 7. And inside of those parentheses, I'm plugging in the x value of 1. So when I do this math, 1 squared is 1. Negative 3 times 1 is negative 3. 6 times 1 is 6. So we really have a negative 3 plus 6, that's 3. And 3 minus 7, that's negative 4 as the y value of our vertex. So positive 1, negative 4, that is our vertex. So in order for us to write an equation in vertex form, you need the a value, which happens to be the same a value of your standard form. So we're going to write y equals the a value, negative 3, open up some parentheses, x minus h, where h is 1, close parentheses squared, and then plus k, and k happens to be a minus 4. So there's your vertex form equation. Does this parabola open up or down? Down. Opens down. You could have found that out even just by looking at the original. It's negative, it opens down. What else? They're asking for the axis of symmetry equation. What's the axis of symmetry equation? X equals the x value of your vertex, which happens to be a positive 1. So the axis symmetry is x equals 1. We know it opens down. What else do they ask for? The vertex itself. The vertex is positive 1, negative 4. So you know what? The 47 is done exactly the same. This video is way too long already. So I'm going to skip 47. You already have the answers provided for you on Edmodo. If you need help, ask me tomorrow. But it's done the same exact way. So let's go for solving these quadratic inequalities. These next few questions are identical, done the same way. How do we do this? To solve a quadratic inequality, you first set it equal to 0. So let's subtract 40. Subtract 40. You're going to end up with 2x squared minus 2x minus 40 is less than or equal to 0. As a matter of fact, we're going to pretend that it's an equal sign, all right? We're going to pretend that it's an equal sign. We'll deal with the inequality later. So we have this quadratic trinomial equation. Let's pretend it's an equal sign and let's solve it. How would you solve this? What's the first thing to do? Factor out what? A 2, bless you. We're going to factor out that GCF of 2. What do we have left? We have x squared minus 1x minus 20. And we still have the equals 0 out here. We're pretending that it's an equal sign to factor, split, and solve. So on the inside, we have that blue quadratic trinomial, which could actually be factored further. What times what is negative 20, that if you combine it together gives you the middle value, negative 1. Be a negative 5 times a positive 4, correct? And we have a 2 out in the front, and it is set equal to 0. So now we're going to use the zero product property to split them and solve. So you're going to have the x minus 5, that could be 0, and the x plus 4, that could be 0, right? If you have something times something and it equals 0, the first something could be equal to 0, the second something could be equal to 0. What about 2? Don't even worry about the 2. You could technically divide by 2, 0 divided by 2 is still 0. Anyway, let's solve both of these simple equations. You're going to get two answers, x equals 5 and x equals negative 4. Now, that's if it were a quadratic equation. Those would be your answers. But it's not a quadratic equation, it's an inequality. And the difference between an equation and an inequality is that the inequality has an area of answers. So what we need to do now to really understand our area of answers is to draw a sketch of our parabola that has the answer 5 and negative 4. So you go to an x number line, plot your points, negative 4 over here in the negatives, positive 5 over here in the positives. Where's your 0 value? It's somewhere in between, right? Somewhere right there. So that means that your y-axis is technically right through there where the 0 is at. Are you with me so far? We have the two answers, negative 4 and positive 5. Does this parabola open up or down? Up or down? Up, because the a value is positive. So if I sketch any parabola that opens up through those 2 points, there's my parabola. Now I need to test a point because it's an inequality. I need to test a point to see if I'm going to shade on the inside of the parabola or on the outside of the parabola. So what point is the easiest to test? 0, 0, which happens to be on the inside. So when we test 0, 0, you could go with the original or with the new modified. It doesn't really matter. I'll go with the original. 0 here, 0 there. The whole thing becomes 0. Is 0 less than or equal to 40? Yes, it's less than 40. So this point in here, this green dot in here, is an answer, which means that all your answers are on the inside of the parabola. Now, if they actually gave you a graph of an inequality, yes, that's what you would shade. But right here, they don't want a graph. They just want the x values. There's not even y values involved. So what we need to do is show where our x values are. So just focus, forget about the xy plane, just focus on the x number line. Are the answers over here, negative 5, negative 6, negative 7? No. Are they over here, 5, 6, 7? No. Where are they at? They're between negative 4 and positive 5. So this is what we're going to write. We're going to write the answer is all of your x's, all of your answers are between negative 4 and positive 5. You put those less than symbols, and because the original had or equal to's, we're going to put or equal to's on these inequalities, and there's your compound inequality answer. So once again, you have to go through all these steps. Pretend it's an equation, get some answers, plot those answers, sketch a parabola, decide if you shaded the inside or the outside, and then you'll know if you're going to write your compound inequality written together or apart. If you would have tested 0, 0 and it wouldn't have worked, then you would have shaded the outside, which means you would have the inequality x is less than or equal to -4, or x is greater than or equal to 5. So when it's apart, you keep it with the word or. When it's together, you put it with the word, or you put it together as a compound inequality. Let's do one more of those. Let's subtract 7x. So we have 5x squared. 5x squared minus 7x minus 6. We're going to pretend it's an equation set equal to 0. And we're going to solve this thing. If you wanted to solve this with the quadratic formula, you could. I want to try to factor, split, and solve by doing step 1, a times c. That'll give me a -30. And then when I think of the multiples of -30, that would be a -10 times +3. That would be the right combo. I mean, you can make a list of the entire -30, like -1 times 30, -2 times 15. But if you see a pair of numbers right off the bat, you don't have to do the whole list. Step 3 is to write your factored form with the ax right here and the ax right there, which happens to be 5x in both. So you put a 5x there, 5x there, plug in that pair of numbers right in there. And then fourth step is to magically reduce. So reduce by 5, you'll get x minus 2. Reduce by, you can't reduce at all, leave it the same, 5x plus 3. So we're going to set this equal to 0, split them and solve. And if you split them and solve, x minus 2 equals 0, that's going to give you the answer x equals 2. Now when you split 5x plus 3 equal to 0, when you split that, you're going to subtract 3 on both sides. You'll have 5x equals -3, which means x equals -3/5. That's another answer. So we're going to plot those points on a number line, because that's the solution if it were an equation, but it's an inequality. So go ahead and plot -3/5 and +2. And we know that those are answers. Where's 0 at? It's going to be somewhere in between. So that means that your y-axis is somewhere in between. And we know that this parabola opens up because the a value is positive. So it has an answer here, an answer there. The parabola opens up. Now, are the answers on the inside or the outside? Go ahead and test the point 0, 0 to figure that out. So when you test 0, 0, you're going to end up with 0 squared with 7 times 0. You're going to end up with -6 is greater than 0. What do you say about that? That's not true. -6 is definitely less than 0. So where are the answers at? They're on the outside, not on the inside. So with regards to your x values, could the x value be 0? No. It's either 2 or 3 or 4 or 5 going this way, or -3/5 or -2, -3, -4 going this way. But it's definitely apart, not together. So I need to write this inequality apart. So I want to say x has to be less than or equal to -3/5, or x has to be greater than or equal to 2. So those are my two answers that have to be written apart with the word or. You guys want a little shortcut? Yes, I love shortcuts. All right. So whenever you have a less than, the areas are going to be together. When you have a greater, the word or is between it. That means it's going to go that way or that way. It's going to be apart. So you're going to have to keep them apart with the word or. Less than, you're going to have to write them together as a compound inequality, like this. Greater, you're going to have to write them apart with the word or. Just a little trick. Moving on. Number 50, 51, 52, 53 is all about division. You could use long division on some of these, but as you could see, we have the sum of two cubes that could be applied. So I hope we remember sum of two cubes. If you have something cubed plus something cubed, that's going to equal a binomial times a trinomial. The binomial will be the same exact binomial without the cubes, a plus b. Then you have your a squared right here, your b squared right there, the ab in the middle. And if you started with the plus, this middle term is going to be a minus. And anything squared is always positive. So a squared is always positive, b squared is always positive. So the question is, could we identify what cubed plus what cubed would give us this x cubed plus 27? What belongs in here? x. What belongs in here? 3. Yes, so the a value is x, the b value is 3. Plug it right in there. So a plus b, that happens to be x plus 3. A squared, that happens to be x squared, minus a times b, that's going to be x times 3, which is really just 3x. And then plus b squared, which is 3 squared, which is 9. So ladies and gentlemen, I've rewritten this as this. And we still have the divided by this quadratic trinomial. So I want to put divided by that quadratic trinomial. So whenever you divide, it's really like a fraction. So instead of writing it over here to the side, you could also just write it as a fraction. All of that over x squared minus 3x plus 9 instead of this. And as you can see, we have the identical quadratic trinomial over the identical quadratic trinomial. We are able to eliminate them. So that means that your final answer is just x plus 3. X plus 3 is the final answer right there for number 50. Number 51, same concept, all right? Rewrite it as a binomial times a trinomial. Rewrite that as a binomial times a trinomial. And then this divided by x plus 5, put it divided by x plus 5. Or you could use synthetic division if you want. But if you could see what cubed, that'll be an x. What cubed, that'll be a 5. So you really have an x plus 5, x squared, minus 5x, plus 25. So the x plus 5 and the x plus 5 cancel out. That's your quadratic trinomial answer on 51. You could have done that with synthetic division if you wanted to. This other one, you could try to factor and then divide, or you could just use synthetic division, but you will have a fraction. So remember, when you use synthetic division, you have to set your divisor equal to 0 to find out what your actual x value is that you're plugging in. So when I set it equal to 0, I'm going to have to subtract 1, then divide by 2, I'll get x equals negative 1/2. So I would have to actually plug in the x value of negative 1/2. And my coefficients would be 18, 9, negative 2, and negative 3. So as you go down, you combine. 18 comes down. And then negative half times 18, that gives you a negative 9. Then negative 9 and positive 9, that's 0. And then negative half times 0 is still 0. And then negative 2 plus 0 is negative 2. And then negative half times negative 2, that's positive 1. And your remainder is negative 2. So what we have here, guys, this is your constant, this is x squared. So what we have here is 18x squared, the constant minus 2, and then the remainder. What do we do with the remainder? You put the minus sign of the remainder there, and then you put 2 over the original divisor, which happens to be 2x plus 1. So there's your final answer using synthetic division. That's a 2 up there over 2x plus 1. Number 52 or 53 could be done the same exact way. Let's identify what we're going to be plugging in to the box by putting this equal to 0. And if you set it equal to 0 and solve correctly, you're going to get x equals negative 1/3. So that's what we're going to be plugging in, a negative 1/3. Making a list of the coefficients, we have 6, we have 5, we have negative 2, we have 3. As you go down, you combine. So 6 plus nothing is 6. As you go up, you multiply. Negative 1/3 times 6 is negative 2. As you go down, you combine. 5 plus negative 2, that's 3. As you go up, you multiply. Negative 1/3 times 3, that's negative 1. As you go down, you combine negative 2 and negative 1, that's negative 3. As you go up, you multiply. Negative 1/3 times negative 3, that's positive 1. Which means that when you combine, you get the remainder of 4. So your final answer will be 6x squared plus 3x minus 3 plus the remainder 4 over the original divisor, which is the binomial 3x plus 1. So you should have a 3x plus 1 right there. So there's your final answer. with the remainder of 4 over the original divisor 3x plus 1. So these next 2 questions, we want to factor completely. We have the sum and difference of 2 cubes. Number 4, 54, they're asking us to factor completely, and you should recognize that that's a difference of 2 cubes, right? If you're able to write it in parentheses, something cubed minus something cubed, then you'll be able to use the formula. Let me write the formula over here. The formula is a cubed minus b cubed equals a binomial times a trinomial. And the binomial is simply a minus b without the cubes. The trinomial is a squared plus ab plus b squared. So how do we learn that? It's really easy. The first binomial is the same thing without the cubes, so it's a minus b. And if you had a minus here, you're going to have a plus in the middle. If it were plus, you'd have a minus in the middle. It's that simple for sum and difference of 2 cubes. So now that we know the formula, let's go back to number 54. What value would be a that if I cubed it, if I multiplied it with itself 3 times, I'd get 27x cubed? What would that be? 3x, right? 3x times 3x times 3x would get you the 27x cubed. And the b value would be what? 4 with a y, right? So we've identified the a and the b. And now that we've identified a and b, we could now plug it into the binomial times the trinomial, okay? Now the binomial is really simple. You just rewrite it without the cubes. That'll be a 3x minus a 4y. The trinomial, that's where you should use parentheses, where you have a squared plus a times b plus b squared, right? So our a value we said was 3x. Our a value is 3x. Our b value is 4y. Our b value is 4y. So we need to simplify that trinomial. So the trinomial in parentheses will be 9x squared if you distribute the power of 2 to the 3 and the x. The middle term will be a plus 12xy, and the last term will be a plus 16y squared. And of course that binomial in the front doesn't change. So that's your answer for number 54. Binomial times a trinomial. Moving on to 55. It's the same formula, but instead of difference of 2 cubes, it's the sum of 2 cubes. If I could change this to be something cubed plus something cubed, then I'll be able to use the formula a cubed plus b cubed equals a binomial times a trinomial, where your binomial would simply be the a plus b without the cubes, and then a squared minus ab plus b squared. So what belongs in the first parenthesis that would give us 125x cubed? 5 with an x. And what belongs in the second parenthesis that would, when we multiply it with itself 3 times, give us 8y to the 6th? 2y to the 2nd. Perfect. So now that we've identified our a value, which is 5x, and our b value, which is 2y squared, we could take the a and the b, plug them right there, plug in the a, the b, and the b, and we'll have our factored form of that sum of 2 cubes. So let's jump right into it. It's going to be a binomial times a trinomial. So the binomial is going to be the same exact binomial without the cubes. So it's going to be 5x plus 2y squared. Let's write that down. 5x plus 2y squared. And then over here we have the parentheses, right? We have the a squared. If you had a plus in the first parenthesis, you're going to have a minus in your middle term, a times b, and then plus your b squared. And let's plug in our a value of 5x and our b value of 2y squared. And let's simplify the trinomial here. So 5x times 5x is 25x squared. Negative 5 times 2 is negative 10. X times y squared is xy squared. And at the very end we have plus 2 squared is 4. Y squared squared, power to a power, multiply, you have y squared. So there's your trinomial. The binomial stays the same. Wait, I should have said fourth. Yeah, my bad. Power to a power, multiply. I was just checking to see if you guys are paying attention. Yeah, right. I messed up, I'm sorry. But anyway, there's your answer. Binomial 5x plus 2y squared times the trinomial 25x squared minus 10xy squared plus 4y to the 4th, power to a power, multiply. Moving on. given a polynomial and one of its factors, find the factors of the polynomial. This is actually from chapter 5, the latest chapter. This should be fresh in our minds. But then again, we didn't do so great on the chapter 5 test. That's not good. So they tell us that this cubic polynomial has this binomial as a factor. And whenever you divide something by one of its factors, it's going to work out beautifully. There's going to be no remainder, right? If I say 12 divided by 4, the answer is 3. There's no remainder. 4 is obviously a factor of 12. So right here, when I'm dividing this by one of its factors, if I divide them, the remainder should be 0. So with that said, we could do synthetic substitution. And again, when we plug in, or synthetic division, when we plug in our value, it's kind of like setting this guy equal to 0. So you're really, after solving, plugging in x equals 3. So that's why we plug in the opposite of what we see here. And let's do a list of our coefficients. The power of x to the third has a coefficient of 1. The power of x squared has a coefficient of -1. The power of x is a coefficient of -5. And the constant at the very end is -3. So as you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. 3 times 1 is 3. As you go down, you combine. -1 and 3 is 2. As you go up, you multiply. 3 times 2 is 6. As you go down, you combine. -5 plus 6 is 1. As you go up, you multiply. 3 times 1 is 3. And as you could see, the remainder is 0. That doesn't surprise me. After all, they told me this was a factor. So when you divide something by one of its factors, you're supposed to get a remainder of 0. So if I already knew I was going to get a remainder of 0, why did I do this? That way I could look at these coefficients, and that is my answer to this original division problem. Okay. So what is my answer going to be? It's going to be 1x squared plus 2x plus 1. And they're asking us to factor. So this is what we call the depressed polynomial, right? It used to be power of 3, now it's power of 2. This is the depressed polynomial, but they want us to find all the other factors. So let's continue factoring this depressed polynomial. So it's as easy as this. It's a quadratic trinomial where the a value is 1. So that means we could set up the parenthesis xx situation and simply think what times what is c, that if I combine together is b, and that will be a +1 and a +1. So what are all the factors of this cubic polynomial? It's x minus 3 that they gave us, and then times x plus 1 times x plus 1. So those are all the factors of number 56. So we're using one of the factors that they give us to find the other factors. So I guess on the multiple choice, since the question says find the other factors, you might just see a x plus 1 or maybe a x plus 1 repeated twice. Let's look at number 57. So let's divide the cubic polynomial by this factor, x minus 1. So what goes inside of the box? +1. Okay, and let's make a list of the coefficients. 1 is on the x cubed, 7's on the x squared, 7's on the x, -15 is the constant. So as you come down, 1 plus nothing is 1. As you go up, you multiply. 1 times 1 is 1. As you come down, you add. 7 plus 1 is 8. As you go up, you multiply. 1 times 8 is 8. As you go down, you combine. 7 plus 8 is 15. As you go up, you multiply. 1 times 15 is 15. As you go down, you combine. -15 and +15, that's 0. And again, the remainder is 0. That doesn't surprise me. And what we have here is our depressed polynomial. Okay, so our depressed polynomial is x squared plus 8x plus 15. And of course, they want all the factors. So let's see if we could continue factoring this. What times what is 15 that if I combine together is the middle value 8? Well, that would simply be a +5, +3. So here are the other factors. If you wanted to write the completely factored form of this cubic polynomial, you would put in this given factor that they gave us. So you'd put times x minus 1. But since the question reads state all the other factors given this factor, you would just probably put these two right there. And that's about it for page 3. We're going to do another video for page 4, the final page.